2. Chemistry for 10 plus 2. Dear students, today we are going to deal with chemical properties of ethers. But before starting with that, subscribe my channel, like it and share it with your friends. Comment it if you like. Let's begin with chemical properties of ethers. In chemical properties of ethers, what we are going to deal with, first let's see. Laboratory test of ethers. Reaction involving alkyl group of ether, in which we are going to see formation of peroxide. Reaction involving CO bond, in which we are going to see reaction with hot dilute sulfuric acid, that is hydrolysis. Reaction with PCl5, phosphorus pentachloride. Reaction with hot concentrated sulfuric acid. Let's begin. React with bases, cold dilute acids, oxidizing agents and metals, but dissolve in cold and concentrated H2SO4 to form oxonium salts. Let's see how it is formed. Here you find ether. Ether, when treated with cold concentrated H2SO4, for the convenience to understand the reaction, H2SO4 is written as HHSO4. Here, oxygen atom is divalent and carries two lone pairs. So, it is bonded to the hydrogen atom of H2SO4 to form oxonium ion. And HSO4 is removed. As you can see here. This distinguishes ethers from hydrocarbons. Let's see the reaction involving alkyl group of ether, in which we are going to understand formation of peroxide. Ether combines with atmospheric oxygen to form peroxide. Let's see how. This is diethyl ether. It combines with oxygen when it is in long contact with it to form peroxide of diethyl ether. All ethers have been exposed to the atmospheric containing peroxide. This is very undesirable reaction. Peroxides are hazardous and they decompose violently at high temperature. First, we are going to deal with reaction with hot dilute sulfuric acid, that is hydrolysis. Ethers on heating with hot dilute H2SO4 gives two molecules of alcohols or phenols. This is an ether. When it undergoes hydrolysis with dilute H2SO4, We can find here ROR, which is ether, and HOH, it undergoes hydrolysis in the presence of dilute H2SO4. As we can see here, the highlighted part which carries ROH is removed, and OH combines with R. Thus, formation of two molecules of ROH is seen here. Let's see the example. Dimethyl ether plus HOH undergoes hydrolysis in the presence of dilute H2SO4. As we can see here, the highlighted part carries CH3OH, that is methyl alcohol, and this OH gets bonded to the methyl group to form two molecules of methyl alcohol or methanol. Thus, mixed ethers under similar condition gives mixture of two different molecules of alcohols. Reactions involving CO bond. Here we are going to see reaction with phosphorus pentachloride. Ethers react with phosphorus pentachloride to give alkyl chlorides. Here this is an ether, ROR dash, plus PCl5 phosphorus pentachloride. On heating gives alkyl halides plus POCl3 phosphorus oxychloride. So here two molecules of alkyl halides are obtained. Let's see the example. Ethyl methyl ether, when treated with PCl5, it gives methyl chloride and ethyl chloride plus POCl3. So two alkyl halide molecules are obtained, methyl chloride and ethyl chloride. Thus, mixed ethers can also be obtained. Under similar condition, gives mixture of two different molecules of alkyl halides, as it can be seen here. Let's talk about reaction with hot and concentrated acid. Ether in hot and concentrated acid like HI or HBr gives an alkyl halide molecule and an alcohol molecule. Alkyl ethers react with hot and concentrated HI or HBr in such a way. As we can see here, the highlighted part is removed to give out alcohol, and X gets bonded to R to form alkyl halide. As you can see here, alkyl halide is formed first and simultaneously alcohol is obtained. So one alkyl halide molecule is obtained and one alcohol molecule is obtained. Here alcohol reacts with hydrogen halide to give alkyl halide and water is removed. The order of reactivity of alkyl halide can be seen in such a way that HI is the most reactive than HBr and HBr is more reactive than HCl. When heated with hydrogen halide, ethers give one molecule of alkyl halide and other molecule of alcohol. We can see here the order of reactivity of HX, that is alkyl halide, can be seen here. Behind it. It takes place in 3 steps. In the first step, ether is protonated to give dialkyl oxonium ion as oxygen of ether is basic. It carries 2 lone pairs, so it is basic. When it is treated with HX, that is hydrogen halide, we can see here ether is protonated and halide ion is removed. Protonated ether is said to be dialkyl oxonium ion. Oxonium ion and displaces an alcohol molecule. So here this is the oxonium ion and here X minus is the attacking nucleophile. The attacking nucleophile attacks the alkyl group and the RO bond breaks, thus forming RX molecule, as it can be seen here. Thus, alkyl halide is obtained and alcohol is obtained. If primary or secondary alkyl groups are present, then lower alkyl group forms alkyl halide. Attack of nucleophile and departure of alcohol molecule takes place simultaneously by SN2 mechanism. In step number 2B, halide ion, which is a good nucleophile, attacks the least substituted carbon atom of dialkyl oxonium ion and displaces an alcohol molecule. This is dialkyl oxonium ion. As here the bond gets broken, we find alcohol is obtained and R positive, that is carbocation, is formed. If one of the alkyl group is tertiary, then tertiary alkyl halide is formed. Departure of alcohol molecule creates stable carbocation by SN2 mechanism. In step 3, reacts with excess of hydrogen halide to give alkyl halide. Here this is an alcohol reacting with HX to give ROH and H, which is protonated alcohol, and halide is removed. This protonated alcohol is attacked by the nucleophile. So, RO bond is broken. Thus, RX that is alkyl halide is obtained and water is removed. Alkyl aryl ethers are cleaved at weaker RO bond to give phenols and alkyl halides. Here this is anisole. To the divalent oxygen atom, the phenyl group is attached and methyl group is attached. When it is treated with HI, that is hydrogen iodide, at 398 Kelvin, CH3I is removed and H forms bond with the oxygen atom to form phenol. And CH3I is removed, that is methyl iodide. Thus, one phenol, that is aryl molecule, and lower alkyl halide molecule is obtained when alkyl aryl ethers are used. ARO bond is stronger because in between the oxygen and the carbon atom, which is sp2 hybridized, there is partial double bond character. So ARO bond is stronger because the carbon atom of phenyl group is sp2 hybridized, resulting to partial double bond character. Let's talk about the chemical properties, especially electrophilic substitution reaction in aromatic ethers. First we will see halogenation, that is bromination of ether. Then we are going to deal with Friedel-Crafts reaction. Next is nitration of ether. Especially in aromatic ethers. Alkoxy group, that is OR, in aromatic ether is ortho-para-directing and activates the aromatic ring towards electrophilic substitution. This is evident from the resonating structures which can be seen here. Here we find one of the lone pair of oxygen atom. The electrons move here in between the oxygen and the sp2 hybridized carbon atom, giving double bond character. Since the density on this carbon atom increases, this double bond of the benzene ring is broken and the electron moves to this carbon atom. Thus, it carries negative charge and oxygen atom carries positive charge, giving rise to the second resonating structure. This negative charge moves here towards this bond. As it moves here, the electron density on this carbon atom increases and this double bond breaks and the electrons moves here on this carbon atom where it carries negative charge, as it can be seen here. Thus, giving rise to the third resonating structure. Carbon atom carries negative charge. These electrons move here in between the two carbon atoms, due to which the electron density on this carbon atom increases and this double bond breaks and the electron moves to this carbon atom. Thus, this carbon atom carries negative charge as it can be seen here, giving rise to the next resonating structure. Now this negative charge which is present on this fourth resonating structure moves here. As it moves here, the electron density on this carbon atom increases and this double bond breaks and the electron moves to the oxygen atom. Thus, here you will find there are two lone pairs on the oxygen atom, giving rise to fifth resonating structure. Thus we can see the negative charge is present on the ortho or para position of the aromatic ring. Thus, alkoxy group, that is OR, in the aromatic ether is ortho-para directing and activates the aromatic ring towards electrophilic substitution. Now, these negatively charged positions at ortho and para position are ready to be attacked by the electrophile, giving rise to electrophilic substitution reaction. Let's see halogenation, that is bromination of ether. Anisole undergoes bromination with bromine in acetic acid even in the absence of FeBr3 as catalyst. Let's see how. This is anisole. When it is treated with bromine in acetic acid, it forms parabromoanisole and orthobromoanisole. Reaction takes place. It's due to the activation of benzene ring by this methoxy group. Now we are going to see Friedel-Crafts alkylation reaction under the topic electrophilic substitution reaction. Alkyl group is introduced at ortho and para position in anisole. The reaction with alkyl halide in the presence of anhydrous aluminum chloride as a catalyst is seen here. This is anisole. When it is treated with alkyl halide in the presence of anhydrous AlCl3, formation of 4-methoxytoluene and 2-methoxytoluene is taking place. This reaction is taking place due to the activation of benzene ring by the methoxy group. Now we are going to see Friedel-Crafts acylation reaction. The reaction with acyl halide in the presence of anhydrous aluminum chloride, a Levy's acid as catalyst. This is anisole. When it is treated with acyl halide in the presence of anhydrous AlCl3, it forms 4-methoxyacetophenone and 2-methoxyacetophenone. The reaction takes place due to the activation of benzene ring by methoxy group. The alkyl group is introduced at ortho and para position in anisole. Let's talk about nitration of ether. Anisole reacts with nitrating mixture to give a mixture of ortho and para derivatives. Here is anisole. When it is treated with concentrated HNO3, that is nitric acid, and concentrated H2SO4, that is sulfuric acid, which is said to be the mixture, or we call it as nitrating mixture, when treated with anisole, it forms 4-nitroanisole and 2-nitroanisole. This reaction takes place due to the activation of benzene ring by this methoxy group. Now we are going to see some important uses of alcohols. Uses of methanol. Methanol is colorless liquid and boils at 337 Kelvin. Highly poisonous in nature, and ingestion of even small quantity can cause night blindness, and large quantity causes even death also. There are various poisoning symptoms. It can be seen here on the screen. It is used as a solvent in paints and varnishes, chiefly for making formaldehyde. Methanol is also used as industrial solvent for oils, fats, and gums. It is used for dry cleaning also, and for preparation of perfumes. It is used as antifreeze agent for automobile radiators in cold countries. It is used to denature ethanol. Talk about some uses of ethanol. Ethanol is commercially prepared by fermentation of sugar in molasses, sugarcane, or fruits like grapes. These sugars, in the presence of enzyme invertase, is converted to glucose and fructose, which undergoes fermentation in the presence of enzyme zymase found in yeast to form ethanol. In winemaking, as grapes ripen, the quantity of sugar increases and yeast grows on the outer skin. When grapes are crushed, sugar and enzymes come in contact and fermentation takes place in anaerobic condition and CO2 is released. Ethanol is used for dyes, oils, cosmetics, and perfumes also. Mixture of 10 to 20% ethyl alcohol with petrol is used as motor fuel. Solid fuel is dispersion of ethyl alcohol in calcium acetate. As ethyl alcohol has low freezing point, it is used in thermometer. It is used in beverages. Ethanol is used as topical antiseptic and in mouthwashes, even in rubbing alcohol. It is used in many cosmetics, in fuel and in fuels also. Ethanol is a colorless liquid with boiling point 351 Kelvin. It is used as a solvent in paint industry. Alcohol is made unfit for drinking by mixing it with some copper sulfate and pyridine, which is known as denaturation of alcohol. Ethanol is used to prepare various carbon compounds like iodoform, CHI3, chloroform, CHCl3, diethyl ether, C2H5O C2H5, and acetic acid, CH3COOH. Let's talk about some important uses of phenols. Phenol formaldehyde is a polymer used in plastic bakelite, phenolphthalein and certain dyes also. Phenol is used. Dettol as an antiseptic contains phenols. Drugs such as salicylic acid, Celol, aspirin contains phenols. Picric acid, which is used as explosive. 2,4-dichlorophenolic acid, which is used as a selective weed killer. Let's talk about some important uses of diethyl ether. It is used as an industrial solvent for oil, fats, gums and resins. As solvent in the reaction of Grignard reagent, it is commonly used. Reaction of Grignard reagent with aldehydes or ketones. Aldehydes or ketones, that is carbonyl compounds, when treated with Grignard reagent in the presence of dry ether gives the adduct, that is magnesium complex, which on acid hydrolysis forms alcohols, and MgXOH is the byproduct. All the three types of alcohols can be obtained by this method. Diethyl ether is used as the refrigerant. Natellite, that is mixture of diethyl ether and ethanol, is used as a fuel as the substitute of petrol. If you like this way of teaching, just let me know by your comments. Subscribe my channel, like it, and share it with your friends. Hit the bell icon to get the latest updates. Thank you.